Welcome to Wavelengths, a podcast with Amphenol Broadband Solutions.
Hey, what's going on, folks? It's Daniel Litwin, voice of B2B. If you're watching this episode, guess what? You're tapping into a part 2 of 2 of a Wavelengths episode with Amphenol Broadband Solutions. If you missed part 1, go ahead and click out of this episode and go watch part 1. If you already saw part 1, you're exactly where you need to be. Welcome back, and we're continuing our conversations. So both part 1 and part 2 of this podcast are exploring some of the nuances of the European broadband market, the technologies, the major market forces and trends, the consumer bottom-up pressures, and just all of the various moving pieces that are shaping the rollout of new broadband technologies, services, and really unpacking the strategy around how broadband players in the space should maneuver some of these market forces and these macro pieces of context. So, we're about to dive into part 2. Again, if you missed part 1, go head to our website, amphenolbroadband.com, or subscribe to Wavelengths on Apple Podcasts and Spotify, and go tap that first part of the episode. Otherwise, let's dive back into our conversation with Carsten Engelke, Director of Technology at ANGA, and Dr. Anthony Basham, VP of Active Products for the EMEA region at Netceed. He's also the president of SCTE. Anthony and Carsten are going to give us more to chew on, more to strategize on, so let's not waste any more time and dive right back in to this part 2 of 2 of a Wavelengths episode.
Yeah, but as broadband networks evolve towards fiber-based infrastructure, security and resilience are now becoming central design considerations rather than an afterthought. Oh, I've established a network. Oh, what do I need to do? I need to make sure this is safe. I mean, fiber networks are now critical national infrastructures, supporting just not internet access, but energy systems, emergency communication, public services, digital economies. Ensuring that these networks are secure and resilient, it's going to need a lot more than we can actually look at. I mean, there's physical infrastructure we need to protect. If that goes wrong, there's nothing there anyway. Power resilience, how do we make sure the power is set there? Network architecture, redundancy of that network architecture, cybersecurity, network integrity, supply chain security. I mean, the whole of this gets more and more, but then we've also got workforce competence. I mean, one of the biggest failures is usually the person pressing the keyboard, and it's always going to be this way. But taking that holistic approach to network resilience, ultimately, resilience in fiber networks won't be solved through a single technology or a policy. This is going to need a holistic approach that integrates infrastructure design, power systems, cybersecurity, supply chain oversight, workforce development. But as fiber becomes more of a backbone of digital societies, building them with resilience is no longer sort of optional, it's essential. And this is where I think the operators, vendors, policymakers, and the broader broadband ecosystem need to start getting this into the fact as well. Now we've got multiple ways of getting communication. You've got copper, you've got fixed wireless, you've got fiber. All of these have different problems. But in the end, we want to make sure when I say hello, it's transmitted as hello and gets all the way through as hello and not go away. This is where it gets so difficult. And I think we're getting there with the thought process of fiber networks need to be built. But then we're opening up this whole Pandora's cybersecurity thing. That box is getting a little bit frightening, especially with the situations going on around the world right now. Cybersecurity is becoming more and more important. And a fiber network should be secure, but you can't get in through the actual fiber. It's a lot more difficult anyway. But you hit something there.
And Tony, you're so right. I had the task to double check an NDR system. That's the network detection and response system. That is a small box, or it's a box which says this is a malware inside your data stream. And you see the data stream running in front of your eyes as a normal technician, you have no chance to handle it. Therefore, we need AI, and this is at the end a benefit for your customers. Let's say first on the business level, that you meet the requirements from the European Commission for the CRA, Cyber Resilience Act, and CSA, the Cybersecurity Act, and you have to meet the permissions from there, and this is a good thing when you say in fiber optic networks, we help you to fulfill the policy requirements. Yeah, it's the same like we helped with the space shuttle the pilot that he not has to press a button at the right time. Yeah, it's not counting down 10, 9, 8, blah blah, and then push the button. And if you count too slow, you miss the right point of time.
But this is also, I mean, we used to have this problem with your picture will have macro blocking your T blocks on it. We don't have time to look at those blocks right now. So you hit something there with the NDR systems that sort of go through collecting the telemetry from multiple points within the network. And these will go in network taps, mirror ports, routers, switches, and to be able to build on this and using behavioral analytics, machine learning, threat intelligence databases, this is going to totally change the way we actually also look at things. But we've also got to think about, will this actually hinder something? So, I mean, NDR looks at deviations from normal behavior. And if we look at deviations from normal behavior 150 years ago, the deviation would be you want a car. Will this actually stop progress, having NDRs in there that stop the change of normal behavior? And what's normal behavior? This is where I'm sort of, NDR has sort of those question marks for me every once in a while. Is wow, we need it because we're not going to be able to analyze all those bits in one go. Or I don't want to sit and look at all those bits and approve them. That's an okay bit that can go forward. We don't have that time. Communication is so important.
Yeah, but you get the pressure from ENISA. They at the end, that's not engineers, that policymakers. They learned NDR, ZM, whatever. It's the right one you have to use, and if you come to an audit in your company, then they like to tick the box. NDR is in place. Well, great.
Yep.
Yeah, and it's also the discussion we have on log files. That we have to store all log files. Yeah, when I come back to the example I said with the Wi-Fi routing table. Yeah, I don't care about the log file. That the log file says to me, well, the routing table is not running. Yeah, the problem is my equipment is not running. My iPhone or Samsung phone, whatever, my smartphone don't get any connection to internet service. You know it from visiting hotels. You went crazy if you like to enter the Wi-Fi network and you have a conference call with your laptop and the system says, not yet, come later again.
Yeah, but I mean, log files have always been important. If you look at it through broadband and fiber networks, the operators are running large fiber networks. Log files was, to be honest, the primary record of truth. When you're diagnosing faults, investigating security incidents, understanding how a network behaved or didn't behave, or who was in, who actually configured changes, the authentication attempts, traffic anomalies, system errors, all of this actually lays in a log file. And this is why they're becoming more important, because the data is going so quick and you're having to try and make sure. And you've got self-healing networks now. The OLT will switch over to another one. I don't know this one. I found a spike. I'm going to disconnect multiple ONTs. I'm going to change how the world thinks. I'm going to move this ONT away. I'm going to refuse it. This can show whether this was a configuration change, power issue, physical link, or just an OLT going rogue. what happens when a network like this does go rogue, if it can? These log files are going to be important. NDR will also come in. It's an interesting time we're going through, but we still haven't built all of the fiber networks yet.
Yeah, absolutely, Anthony. That's the right point. As I said, AI for autonomous networks, self-healing networks. I think that was 3 years ago the buzzword we had at ANGA.com. But I cannot see any product right now because AI runs much more faster than the or machine learning at the end needs AI, and as you said, the information across your network runs so fast that it's not possible for an engineer to react. Yeah, therefore I need some orchestration on this way that they say, okay, this happens and I have to go these steps automatically right now. And therefore I love the picture with the space shuttle, just the moment when it turns to come to Earth. Yeah, and this was a technology based on very small computers. Yeah, it's not comparable with the powerful computing we have today. But therefore, I think it's great when the industry and the European Commission helps us to bring all these helpful AI services in place and not stopping us to different reasons. I think you have to be careful with AI, I'm sure. But at the end, when we talk about networks, we have to define what is the level where the networks can be supported for self-healing at the end. Yeah, the proactive network maintenance. It's so easy when, as I said at the beginning, when we bring the equipment for the networks in line in each country, then we can say from the AI perspective, well, service technician, you have to put these things on board of your car and you have to drive out and you have to double check maybe this one is gone or another one, and you can replace it and you don't have too much truck rolls. Yeah, and then we come again to the sustainability work. It makes no sense that our technicians get a taxi permission. They are not paid for driving from the headquarter to the customer back and forward and back.
But now, Carsten, think about it. How much equipment do these techs need to have? They need something for copper. They need something for DOCSIS. They need something for fiber. This is also where you have to pick the right technician for the right job. So now you're also looking at how you get a technician, the right technician, to be there at the right time with the right equipment in the right area at the same time as there's a customer complaint.
One thing after our last podcast, I was asked from people, well, you discussed great ideas like we do today, but how we can give our technicians the right skills, where we found people which can handle AI. It's a change of a change of the paradigm at the end. It's not your normal work that you get a screwdriver and you make this one or that one. It's more an intelligent service based on AI information. And therefore, we need training. And I'm sure that with the SCTE, with your SCTE, Anthony, we are able to make a training for the European area. But for me, it's important. That was my learning also from DOCSIS, it's important that we stay close with our US friends. That at the end, we need a global training session for the technicians. Otherwise, we will fail. We have good ideas, good solutions in place, but no one can handle it.
No, I mean, this is where AI does play into this. When you start looking at AI, how's it going to influence us going forwards? This is going to transform how we design, how we monitor. If you look at network operations, fault detection, how networks are planned and deployed, automation, self-optimizing of networks, security and threats. But still, as we go through all of that, the human role will still remain critical. This is one of the areas that people have really looked at me and said, yeah, but AI is going to take over everything. Despite all of these advantages, AI does not replace a network engineer. Fiber networks are still going to require human expertise to design the architectures, interpret complex events, and make those strategic decisions. AI is going to act as an augmentation tool, allowing engineers to manage networks that are far larger and more complex than previously. But this professional training you were talking about, knowledge sharing, they can remain essential in this. And the SCTE does play a role, ANGA plays a role, Amphenol, all of these play a role in making sure these networks and the workforces develop. I mean, if you only had one version for everything, no one would buy it, because I'm not buying the same as him. This needs to also develop. But there's so much going on in fiber at the moment. So it's an interesting time we're in. A lot of this is about taking the right decisions right now and making sure we're actually getting more fiber into the ground, getting more connected. There's been a big push on fiber build. Now we need to get connections.
I remember my time when we started with monitoring systems in DOCSIS. You remember the EMS? Yeah.
EMS.
It's at the end we need a solution which is a global solution, and we have the same training as easy as possible for our technicians, so that they will use it, that they go home to their wife and say, hey, there's such a fancy gimmick in our network right now, and it's a fun to work with it. That's for me the importance to take all the people around us on board, and we go in the same direction.
But I think we're also there where there's a lot of training that needs to be done, and it's in multiple areas in here. We also have to think about the safety aspects of fiber. Fiber's not something you can play with. It's not for fun. And this is also where I'm sort of, are we there now where we can get a workforce trained so they know exactly what to do whenever on multiple systems, multiple different vendors, multiple different types of fiber? Now we're going towards the hollow fiber concepts. This is also a factor that's coming in, hollow fiber. When you start thinking about fiber used to be fiber, but when you've seen a piece of fiber, ordinary fiber, spliced with a piece of hollow fiber and it still works, this is where even my brain starts to look, well, this shouldn't be good. But that also works. This is where we're getting towards the technology side of this, and things are still evolving, things are still developing. And I'm interested in what's going to happen. I mean, the next 3 to 5 years is going to be very interesting. This is where we need the big push and pull and getting connections.
I think from the engineer's perspective, it will be a great time. But well, let's say it's 5 years that the engineers have fun. But after 5 years, should be the result that all technicians, all people around us, see it as a daily business. Yeah, remember when we start with Microsoft MS-DOS. I like MS-DOS because you were possible to maintain your network. When I stay today on my iPhone and the app is not working, I have no idea what is the reason. Yeah, it's there maybe the IP connection not running, blah blah. MS-DOS, many people hate it, but it was a good thing to maintain networks. Yeah, I used it when we started with internet services very often. There were only DOS or Microsoft devices out there, and I'm the guy who uses very often the CMD stuff on my laptop.
I still use CMD. Come on. All engineers use CMD.
Yeah, but you see it on Unix applications. They have it on board. Yeah, and here in our world with our customer, the IP config /all blah blah. It's a normal thing, and the customer makes such a big eyes. What you are doing here? I never saw it. For the hell, yeah. Or the PNG thing. Yeah, it's a first thing that you test. Do you have any connection to outside servers? And therefore, it's important that you have a good documentation on your network so that you know where.
This is also where we're playing with, does the computer work? And this is coming back to your documentation. Where is the problem? How do we find out where it's gone wrong? And this is, we're still going to need these intelligent people that use PNG and start finding out, okay, where did it go? Trace route, find out where did it stop? Oh, I got to there. That's not very good. That's only locally. I haven't got out into the world. My router's turned off. Easy, fault finding.
And you will see it with all the buzzwords around us from the European Commission with quantum computing and blah, blah, blah. Whatever happens, yeah. You will see many engineers are lost in this world. And it's important, we have such a strong progress here in technology in this 20 years here in this century. It's important that we bring people on board and make it not as atomic knowledge. Yeah.
Oh, you've just brought atoms into it anyway. I mean, think about fiber as a backbone for a quantum network. Quantum networks communication are expected to rely that this is what fiber is going to be used for going forward. Fiber can transmit quantum signals over distances, connecting quantum computers, research institutions, secure communication systems. But quantum signals are extremely sensitive to loss, noise. That's where the existing fiber structure may need sort of specialized components, quantum repeaters, ultra low loss optical links to support sort of these large scale things. We think fiber's going to be there forever, but this is where you also look in. You mentioned quantum networks. This is going to get more delicate because quantum signals are not nice signals to look. They have to be looked after. So if you think about now, we're building a fiber network for quantum computers.
Resilience and life cycle is very important here, right? We're dealing with hybrid systems. We're dealing with rolling out the infrastructure for the future of European connectivity. But to your point just a few minutes ago, that meta of technology, of standards, keeps changing, keeps improving. We almost feel like it speeds up year over year. So if operators are building infrastructure today that they're already maybe a little behind on, right? That then needs to last another 5, 7, 10, 12 years. What does it really mean to build for resilience from the start instead of retrofitting later? How do you plan for the retrofitting? Like, how should the industry be approaching these fiber rollouts, knowing that technology standards may continue to improve while they're midway through the project?
That's a absolutely important question, and we have it here in Europe with the Resilience Act very hard before our eyes. We do it as ANGA in this way, that we talk with the Ministry of Inner Affairs and with the armed forces What's their requirements for resilience? If something happens, we have to serve also the armed forces and the Ministry of Inner Affairs. That's an important thing. And when we start building today a fiber optic network, we have to think resilience from the beginning. That means the planning teams who build the networks, we have to think about a clever redundancy. We have to think about clever equipment which is protected against sabotage or whatever. There are equipment available on the market, and we have to think how to bring this equipment in place in the existing networks. And right now, it's a right point of time to start with it. When you do it later, then you have to exchange all the connector fields and connectors, blah, blah, whatever. And you know there are fiber optic lines in place for the armed services. They have different requirements.
Where standards matter because the market's going to change faster than the assets here. The technology meter will keep moving. Standards will improve. Vendors will reposition. Architectures that look optimal today may look transitional in 5 years' time. And this is exactly why standards matter. Standards are what's going to protect operators from being stranded by change. They improve the interoperability, reduce dependency on bespoke engineering, support workforce mobility, and make future upgrades a lot easier. I mean, in a fragmented European market, standards also help create continuity across the borders, vendors and generations of equipment. For an operator that's behind right now, standards are especially important. They can reduce the cost of catching up and lower the risk of building something that's going to be obsolete soon. I mean, we spoke about it a while ago. How do we make sure our armed forces have the same connector on their generators? Sounds like a stupid thing, but they don't always. And this is also what we need to start looking at, how this becomes resilient. But here, I think this, to your point, Daniel, this is where standards matter because they're going to keep the market changing in the right direction. But this means also our standards have to be quicker. We have to be able to develop standards to move with the market, move with the changes, but also to secure a standard for a longer time, ensuring that operators don't go out, investors don't put money in the wrong thing.
Absolutely, that's an absolutely important topic, and we need international standards, not national standards. We need something like Senelec, IEC, ANSI, whatever. Yeah, and it's important to have also a good connection to our friends in the US, because it helps that we build telecommunication networks on a global standard. Yeah, that's the advantage of telecommunication. It's important that we have the same internet protocol running across the globe. Otherwise, you don't get the connection to shopping things or information things. And we don't need a divide in the internet world. It's important right now that, for example, the south of Africa get the same information on the same devices like we get in Europe or in North America.
Yep. Yeah, but here I also think when you're looking at this, the operators who are going to win, they're not necessarily going to be the ones with the newest slide where the fastest claims or something in all of this. They're going to be the ones who build a network that can absorb change without breaking, commercially, operationally, or technically. This is where resilience starts coming in. And that's why I think a lot of this, it will be defined by how good is your fiber network.
Yeah.
So it's down to how you build a fiber network. We said earlier, things will change, the two ends will change, technology on both ends will change. The bit in the middle, I hope we never have to see it again, where it stays down there for another 50 to 100 years. That would be a goal in itself. But we have to make sure it's built resiliently enough for all of the things that could happen to it. But commercially, operationally, or technically, this is where we need that resilient side of it.
Absolutely, and I'm sure that sorry, Daniel, that we have a view now on Europe, that SCTE and ANGA is able to force this in the European standardization world. We many years ago we talk about maybe the help of the European Commission with a EU-founded project. I think right now it's the right time to start such a project with the result that we get a new standard on the requirements of resilience, security, whatever. Yeah, all the requirements made by the European Commission to the operator, we have to bring it in line. And when we start the work, I'm sure with our Senelec and ETSI work we do, that we have the people from the US with us.
Just looking at this from sort of the other side of it, we need to get everybody aligned in this, but we're also looking at the moment, we need to build for long life, not just a fast rollout. And that is two contradicting things. You want to have long life, but you want a fast rollout. Which one are you going to do first? Because everybody wants things to work immediately. So resilience in the build is going to be a factor that plays in here. If we start looking at sort of some principles and say, okay, we're going to build the passive layer for endurance and the active layer for replacement. We already said this earlier. So this will also change. The civil layer should be overbuilt where sensible with the spare capacity, but it needs good documentation, accessible chambers, route diversity, room for future fiber counts. The active layer should be treated as changeable, electronics, optics, software stacks. And this will be for all of us. It doesn't matter where we are. We need that endurance in the passive layer. And we need that replaceability or circularity. Something can move out. You can replace it from something else. You can build it. It is an active in itself and starts building its own, moving on. And this is going to be where we're having to play in this. So build for long life, not just for the rollout. And this is where I think we've gone wrong in the start. It's been built for the rollout. How quickly can we get it down there? How quickly can
I think that's really important for the topic resilience and cybersecurity, because the European Commission forced us to write playbooks how to handle the impact of resilience or natural disaster, whatever. And these playbooks should be in a common way across every European countries, in best case globally, and therefore it's clear all the playbooks will look in the same way, and then we need a standard and we need equipment that you can put out of your pocket, lay on the table, and say that helps me today. Yeah, I have the easy example. If a American truck from the US Army comes to my data center and asks, "Hey, I need a power supply," then I connect. I say, "I have enough. You can have my power." But this is in Europe, in most countries, 230 volts, and you have in the US 110, and you connect the car, you ask just for a power supply, and it makes thump, and the truck is destroyed.
But then you're back to standards. I mean, there is a standard in US, there's a standard for Europe, 230, 110, but this is where standards play in. As long as you know the standard is there, It's not a problem.
And if you write in the playbook, you have to bring such a transformer from 230 to 110 in between, then both sides are absolutely happy. But no one said to our operators, you need this one. Yeah, at the end, we have to work together. We work together for a free world. And therefore, it's important. My time at the army was in this way. We were able to connect everything. Yeah, don't care if it UK telephone line that was connected to the German armed forces and vice versa. France was the same. Yeah, very easy. But right now with fiber optic telephone lines, it's not so easy. You cannot connect the fiber line in your CPE and it works. No, it's different. Yeah, we need the interfaces. At the end, the playbooks is based on interfaces, and we have to define these interfaces in our fiber optic networks. And maybe, Daniel, that helps you with the answer of your question.
I'm glad Daniel said, can you do it just short, guys?
I think, folks, we're going to have to call it there. We're at 90 minutes now. So with that, there were quite a bit more questions we wanted to hit on, but we can always cover those in a follow-up episode. So another reason to just get back on here and do another 90. So with that, folks, thank you to the two of y'all for y'all's insights today, for helping us get this really in-depth conversational look at the European broadband market today. It's clear that there's no one major trend defining the market. There's no one major technology. It's this confluence, this intersection of legacy systems, new pressures, new technologies on the horizon, workforce challenges, supply chain challenges, political ambitions, everything in between. But I think we end today with an optimistic note that the market is moving ahead with clear goals. The North Star is clear. We need fiber across Europe. So now it's really about weighing these priorities, making a sense of how to really balance some of these distinct pressures so that we can get active, get fiber deployed, and finally get that gig network capacity to Europeans across the continent. So with that, thank you to our two guests here today. Again, we've been chatting with Dr. Anthony Basham. He is VP of Active Products for the EMEA region at Netceed and president of SCTE. Dr. Basham, if folks want to learn a little bit more about you, they maybe want to tap your thought leadership, learn from you, how can they get in touch?
They can get in touch in multiple ways. The easiest way is, of course, write into me at president@the SCTE.eu. That's the easiest way to get hold of me.
All right, easy peasy. And LinkedIn too, I guess.
LinkedIn, yeah, LinkedIn's always a good place, but you know that. If they just put my name in, there's not a lot of me, so it should be okay.
Hey, lucky you. I love it. And also rejoining us for part 2 was Mr. Carsten Engelke. He's Director of Technology at ANGA. Carsten, thank you again for your insights here today. If folks want to get in touch with you and learn a little bit more about your work, how can they do so?
Yeah, same way like with as Anthony said, LinkedIn is a good place. I will answer all text messages coming there, or they can use Carsten Engelke at ANGA Alpha November Golf Alpha .de Delta Echo, and it's very easy. You also find my contact details, also phone number, stuff like this, on our website, www.anga Alpha November Golf Alpha Delta Echo. And it's very easy. And my name, I can spell it for people who like to use it. Carsten is Charlie Alpha Romeo Sierra Tango Echo November Echo November Golf Echo Lima Kilo echo@anga.de. So, and Daniel, I will say from my side, a big thank you that we were able to be your guests. You made it very great, and sorry that we took over the European discussion here between Anthony and me. And I will also thank Anthony so much to do it with me here on the Amphenol Broadband podcast. That's absolutely great, and best wishes to the staff of Amphenol, and we will say thank you also to Greg and Casey that they make it possible that we had this great exchange with you, Daniel, here on your platform. Thank you so much.
Yeah, absolutely, guys. Well, you guys are the experts, so I'm glad we were able to give you the platform to chat it out and share your expertise with the audience. So thank you again to Carsten. Thank you again to Dr. Basham. We'll be in touch, folks. It was great getting to chat today.
Thank you so much. Take care.
And thank you, everyone, for tuning in to today's episode of Wavelengths. If you like what you heard and saw, and you want to tap into previous episodes, or you don't want to miss out on maybe part 3 here of our European conversation, make sure that you subscribe to the podcast on Apple Podcasts and Spotify, and make sure that you check out our website at amphenolbroadband.com for previous episodes of the show and more information about our solutions and services. I'm your host, Daniel Litwin, the voice of B2B. We'll catch you on the next episode of Wavelengths.